My name's David Laws. I'm Semiconductor Curator at the Computer History Museum in Mountain View, California. I joined the semiconductor industry in 1963. I moved to Silicon Valley in 1968 and spent nearly 50 years involved in the building of computer chips and software to support them. Currently, I am associated with the Computer History Museum as Semiconductor Curator and have a very special interest in the history of Silicon Valley and the people and products that have come out of this area and that have made a vast difference in the world we live in today. So this morning's talk is Silicon Valley, a century of technological and entrepreneurial innovation. So where is Silicon Valley? Silicon Valley is our area at the southern end of the San Francisco Peninsula, centered around Mountain View, where many of the early chip manufacturers started business in the early 1960s. The name Silicon Valley is actually relatively new. It came about in 1971 as a result of an article published in Electronic News, an industry newspaper, on January the 11th, 1971. So we're just coming up to about 50 years of the name Silicon Valley. But in fact, the area was supporting technology and other industries for many, many years prior to that. Many people will come to Silicon Valley and try to replicate the success back home without realizing that it took about 50 years or more to build up the infrastructure and the background that makes the valley such a success as a technology innovator. Why is it called Silicon Valley? Silicon is the second most abundant element on Earth, and it is the major material used in the manufacture of computer chips. Sand on the beach is a form of silicon, which when melted at very high temperature, about 1200 degrees, can be formed into ingots, which are then sliced and cut up and treated both chemically and physically to create an integrated circuit. Microelectronic circuit, computer chip, goes under many names. Basically, little electronic circuits that can perform many, many different kinds of functions, both in the digital and in the analog mode. And portents of the future began to emerge in the area around Palo Alto and Stanford University early last century. There were many, many people involved in the development of technology, particularly related to communications technology, associated in one way or another with Stanford University. This picture shows many of the pioneers of technology of that era in front of the Memorial Church on the Stanford campus. In fact, Stanford claims that nearly 40,000 active companies can trace their roots back to Stanford. This statement was made back in 2012, so there's certainly been a lot more since that time. One of the earliest companies that we have records of is a company called the Federal Telegraph Company. It was founded in 1909 by a young Stanford graduate, Cyril Elwell, who took over the beginnings of a small company that was developing very, very early techniques for radio communications. He licensed a technology called an arc transmitter that allowed the transmission of radio signals over long distances. And he had his lab in this little cottage in downtown Palo Alto. And the most important development that came about in that was the use of the vacuum tube as an amplifier by the inventor of the tube, Lee DeForest, who worked for Federal Telegraph around 1910, 1912. And Elwell used that technology to make what is noted to be possibly one of the first mobile phone calls that have been documented. He, with the help of two assistants, carried a large antenna, several Leyden jars for electric power, and a little transmitter in a backpack, and made a radio telephone call to downtown Los Altos. And Federal then became quite successful in developing some very large transmitters that were used by the US Navy during the First World War. In typifying an early startup in Silicon Valley, several companies and ideas sprang out of Federal Telegraph Company, not the least of which was the first scheduled radio station in San Jose. Today it's KCBS, broadcasting out of San Francisco. The Magnavox loudspeaker company, and also the development of technology for aerial equipment that was small and light enough to be carried in airplanes to permit communication while flying in the aircraft. So the background of the technology goes back, as I said, to the early 1900s. And then, beginning in the 1930s, just about every decade, 30s, 40s, 50s, this slide shows that a different technology came out of Silicon Valley, each one succeeding the prior one in some way, but building on its technology, and each developing into a very significant industry which contributed to the fast growth of the area as a technology innovator. The first company on the list here in the 1930s is Litton Communications. And Litton is just one of many of the companies that we'll examine over the next 20 minutes or so, which are scattered around this area around between Menlo Park and Sunnyvale and into South San Jose. And Litton was started by an engineer, Charles Litton, who developed a technology for making a glass lathe technology that allowed the production of vacuum tubes in very high volume and lower cost and more consistent quality that were used in the radio industry. Many companies licensed the technology from Litton, and he grew into a substantial company. As he commented, I woke up one day out of the clear blue sky, found myself the sole owner of $1.5 million concern. He sold the company in the 1950s, which then grew to be a major defense contractor for the United States. Now, Litton's success allowed him to donate some money to Stanford to Frederick Terman, who at that time was provost of the university. That allowed Terman to try to attract some of the engineers that he had trained at Stanford back to the area. Many of them had to move out to the East Coast because there just was not a lot of electronics employment in the area at the time. And what that enabled him to do was to encourage David Packard to return to the area, where Packard teamed up with William Hewlett to create the Hewlett Packard company. Hewlett Packard, founded in 1938, actually was founded in this building here, 930 Addison Street in Palo Alto. The building is now owned by Hewlett Packard. It's private, but you can see it from the street. And at the side of the building is the typical Silicon Valley garage that was used by a startup. Hewlett and Packard would work in this building during the day, creating their first piece of equipment, an audio oscillator that made signal tones that was very reasonably priced, very useful for a lot of different applications, but most particularly the first sale that the company made was to the Walt Disney Company, that purchased 8 of these oscillators, I think. That was their first volume purchase at about $75 a piece, I think, for use of the production in the movie Fantasia. This is an example of one of the many different artifacts associated with companies in Silicon Valley that are included in the collection of the Computer History Museum. The 1940s, the next decade, which I've determined here, the defense systems era, showed a lot of new applications for the electronics technology that was being developed. Airborne radar, ECM, missile guidance technology used a lot of these early electronic systems. And the company that I have chosen here to kind of represent the venture approach and the startup approach to the success of Silicon Valley is Varian Associates. Varian was actually founded in 1948 as a company to exploit the development of the klystron device, which had been invented by Russell Varian and Professor Hansen at Stanford University in the late 1930s. And basically what it allowed the designer to do is to build a piece of equipment that was small and light enough to function as a radar system that would fit into an airplane. Radar was invented in the early 1930s in England, but used very large magnetron devices to generate the radar signals. So this development by Varian and his associates played a significantly important role in World War II, especially in helping the United Kingdom survive after the Battle of Britain in 1941. This is an example of another artifact that's in the Computer History Museum collection. a very early klystron built by the Varians. Other applications of microwave radar, of course, are familiar to us in the form of microwave ovens and very importantly in transmission of radio signals across very long distances. Varian actually started outside of the Stanford area. I think they were in San Carlos, but in the early 1950s, Stanford had a very large area of real estate to the south of the campus that they developed as an industrial park. The idea was to put together companies that could take advantage of the technologies that came out of Stanford, and that could be a sharing of minds and ideas in the development of these. And Frederick Terman was a very important factor in attracting a number of companies to set up facilities on this. This picture shows the junction of Page Mill Road and El Camino Real in Palo Alto, and Varian is the company at the lower center of that picture. And this is the building that the company started off in the park. Built in 1951. The developers of the building were so unsure that there was really any future in this electronics technology or that kind of role, so they actually designed it in the form of a high school campus so it could be put to some use should this new movement to develop industrial activity on the park fail. Another important company that set out on that campus after they moved from the garage was, of course, Hewlett Packard, and they set up a major headquarters on Page Mill Road. And the offices that were first developed for the founders, this is William Hewlett's office, this is David Packard's office, looking exactly as they would have been with a mid-century modern furniture in the early 1950s. And this is in the Hewlett Packard Customer Welcome Center on the campus and is open to customers of the company. The next generation of technology came about in the 1950s. I'm calling this the magnetic storage era. And the first company to really take advantage of this technology in Silicon Valley was the company called Ampex. Ampex had become a major manufacturer of magnetic tape recorders, audio tape recorders. And in 1956, they developed the first commercial videotape recorder for use on recording television programs for broadcast at a later time. Ampex became a very successful company in the Valley, spun out many companies and engineers who moved on to other activities. Another application for magnetic storage was for the storage of data for computers. IBM, under the leadership of Reynolds Johnson, set up a lab in downtown San Jose. The idea was to try to take advantage of the people and some of the ideas that were growing in the Valley for the IBM Corporation. And in 1956, they came up with essentially the world's first disk drive, whereby data were recorded on a high-speed spinning disk and could be accessed fairly rapidly for a computer, whereas using the old tape drives, the access was too slow for real-time use by a computer. IBM set up in this building, which was used for many years after IBM left as a Superior Court building, and it does have a plaque indicating the history and the important role it played in the development of disk drive technology. The first disk drive that IBM built was this picture on the right-hand side, a very large mechanism built as part of a complete computer system, random access memory and control for use for businesses. And if you can imagine that as a disk drive, the thing weighed over a ton. I think it's about 50 very large 24-inch diameter disks, and the total machine held the equivalent of 4 megabytes of data today. IBM went on to turn this into a vast business, and a whole campus was set up in South San Jose that went through many generations of disk drive technology. And this is an example of one of those early RAM-ACK disk drives, which has been reconditioned and is now in operation in an exhibit at the Computer History Museum. Disk drive technology went through very, very fast growth For example, the picture on the left is one of those early RAM disk drives, all 4 megabytes of it being shipped on an airliner. They took a forklift truck to move the thing around. On the right is a picture, and this is now itself a historic device that shows that by 1992, that same, much more than that data had been integrated 1 gigabyte onto a little disk drive, as small as the little hamster shown in the picture here. And the technology continues to evolve. Today, at storage density that are from about 2,000 bits per square inch on that RAM drive to over 1 trillion bits per square inch by 1915, and prices have dropped from as much as $10,000 for that RAM disk drive to less than 1 cent per megabyte of data. So incredible increase in the capability of drives. 1960s began what I'm calling the semiconductor era, and semiconductors came to Silicon Valley with William Shockley. William Shockley was a co-inventor of the transistor back at Bell Telephone Laboratories in 1947. He had tried to set up his company on the East Coast, but finding no funding for that, moved out to the West Coast, where he teamed up with Beckman Company to fund the Shockley Semiconductor Lab as a startup in Mountain View on San Antonio Drive. So this is a picture of that Shockley Semiconductor Lab from 1956. Former life, this had been an apricot packing shed associated with the agricultural industry of the area. Shockley was a very difficult man to work for. He was brilliant, but he alienated his employees, and 8 of them decided that they would prefer to work out of his company and spun out with financing from East Coast company Fairchild Cameron Instrument Corporation, founded Fairchild Semiconductor Company in 1957, and moved into this building at 844 Charleston Road in Palo Alto, just on the borders of Mountain View. Actually, probably less than a mile from the Shockley building where he'd been working previously. The most significant technology that came out of this activity at Fairchild was the birthplace of the modern microchip, which came about in 1960, and this is marked as a California historical landmark. There were 3 important developments that brought about the development of the microchip. Jean Henny, one of the founders of Fairchild, had developed a technology that's known as the Planar Process in 1959. This allowed manufacturing of semiconductor devices to transition from handcrafted, one-at-a-time process where each transistor was built by hand to essentially a printing process by producing a whole number of transistors using a photolithographic printing technology on a wafer of silicon. They could then be cut up into individual devices, such as the device on the right here, which is the first transistor developed using Henny's planar technology in 1959. Henny's boss, Bob Noyce, one of the founders of Fairchild, and later was the founder of Intel, realized that the process that Henny had come up with, this planar process, had this very flat surface. It was protected by an insulating layer of silicon dioxide, and that instead of cutting all the transistors up into separate pieces and putting them in a separate package, they could basically interconnect those transistors by depositing metal leads on top of the insulating layer and cutting a window through to contact the transistors underneath. And this is the very first monolithic integrated circuit that was developed by Fairchild in 1960 and introduced in 1961. One member of Noyce's team, Gordon Moore, a chemist, realized as they worked to make better and better integrated circuits with more and more components on a chip, in about 1964 he plotted 4 points on a graph showing the increased complexity that improvements in technology, better ideas, better manufacturing methods allowed them to put more and more transistors on a chip. And by drawing a line through those points, he projected that by 1975, it would be possible to put 65,000 transistors on a single piece of silicon. That indeed had become known as Moore's Law. Moore's Law is one of the most, it is not a law of physics, became a self-fulfilling prophecy, because everybody could see that their competitors were getting more and more transistors on a chip each year, and there was a tremendous effort by the worldwide semiconductor industry to put more and more of these devices on a chip. And as I say, by 1975, you could put about 60,000 transistors on a chip. The site of some of these developments is marked in downtown Mountain View at 391 San Antonio, the site of the former Shockley Lab, by a couple of IEEE milestones. One celebrating the development of the Shockley Lab and the work that came on there, and the second celebrating the concept of Moore's Law. And these are marked by a number of pieces of artwork on the street outside on San Antonio, and a giant 20-foot high silicon atom, which is on the inside plaza there. Probably the most important company in the Valley that came out of the work at Fairchild was yet another spin-out. Fairchild spun out of Shockley, Intel spun out of Fairchild. Gordon Moore and Robert Noyce founded Intel in 1968 in Mountain View, shortly after it moved to Santa Clara. And they contributed to two significantly important product areas in the microelectronic business. Their first focus was on high-density semiconductor memory products, but several years later realized that there was a much better business opportunity in the development of microprocessors, devices that we know as a computer on a chip. This is an advertisement for that first microprocessor that Intel developed in 1968 that they announced as a new era of integrated electronics, a microprogrammable computer on a chip. That device was developed for a Japanese company, Bizicom, who needed far more capability than the calculator chips that were then on the market, and Intel developed this special chip for them, which turned out to the concept that the designers followed was to make it a programmable device, so it could be used to create many different kinds of applications, not just in the calculator that was originally intended for. That first chip, that first microprocessor that Intel developed in 1971 had as much as 2,300 transistors on it, and that was pretty impressive for those days. And that same technology, following Moore's Law, has seen an incredible growth, of course. These are just two examples of microprocessor units developed by Intel. By the 2010s, the processors carried millions of transistors. I think this one has a couple of million transistors on the left. By 2020, 10 years later, we're up to billions of transistors on a chip. This has, I think, 3 or 4 billion. There are some specialized graphics accelerator and other processors available from NVIDIA, AMD, and other companies today that have 20 or 30 billion transistors on them. And what these integrated computing devices did was enable a whole new business to be established in Silicon Valley. In the 1970s, began what we're calling the personal computing era. One of the first applications for personal computing was essentially the video game. The first video game that got widespread use in 1972 was built here by Atari. This particular model actually did use integrated circuits, but it showed the concept of providing personal computing applications for consumer use. Some of the earliest computers coming out were initially used by hobbyists and small businesses. This is a very early computer from Apple, the Apple I, that was introduced in 1976. Another very popular machine came out a year later, a home personal computer, the PET, from Commodore Technology. And by 1981, the electronics in these machines had been shrunk small enough to fit into a portable device case. And this is one of the first portable devices from Osborne Electronics. very primitive in its capability in that tiny little screen, but has led to, was the predecessor for so many devices today. An important aspect of the development of small processors, what they were no longer the province and only be afforded by large businesses and corporations. Individuals could have these personal computers. And an important facilitator of the spread of personal computing in Silicon Valley was the Homebrew Computer Club, a group of people that would get together once, a couple of times a month in Menlo Park and later on the Stanford Linear Accelerator campus to talk about, share ideas, swap ideas, and basically pioneer the fast development of personal computing technology and applications for it individuals. This is a view of one of those meetings of the Homebrew Computer Club. This was probably about 1975-76, and a very regular attendee of that was the young man on the left-hand side in the picture on the right, Steve Wozniak, a brilliant young engineer who developed that first Apple I computer, and of course worked together with Steve Jobs, who was the marketing genius behind coming up many of the ideas that would make computers popular amongst people that were not particularly computer savvy. This is where the first Apple computer was built. This is Steve Jobs' step-parents' home on Crist Drive in Los Altos. Still looks pretty much like this today. So this is the first headquarters of what for many years was the world's most valuable company, Apple Computer. This is that first Apple I that came out of the activity in that house. This one is owned by the Computer History Museum and is one of the exhibits in the Revolution exhibit. This is a machine that is probably one of the few computers that are worth more today than the date they first went on the market. Essentially, for $666, you would get a bag of components to build your computer on this printed circuit board. You then have to go off and find your own monitor, keyboard, and a tape drive to load programs into it. These machines, of which there are a handful still working in the world, have sold for several hundreds of $1,000s at auction and basically pioneered personal computing outside the Valley. So the next generation of technology that came out of the area, and I'm calling the 1980s the computer networked era. In the early days, if you wanted to share data from one computer to another, you would put it onto one of these floppy disks and carry it in what's known as the sneaker network to wherever you needed to have the data on another computer. What the network era allowed us to do was to have many, many computers interconnected and share data over individual PCs. Many different techniques were developed for building computer interconnection networks, but one of the most enduring of these came out of Xerox Corporation's facility at the Palo Alto Research Center. It was established in about 1970 to create different electronic technologies for Xerox concept of the office of the future. On the left-hand side is a very important machine that came out of that era, the Alto, an individual workstation that had many features that we have come to accept on computers today, both in terms of the software, the presentation of the data on the screen, and most importantly here, the fact that the network developed by Robert Metcalfe and others at Xerox allowed all these machines to be interconnected together. People could share data, making the use of the technology much more efficient. So PARC still exists today as a Xerox company in Palo Alto, continuing to work on technologies that benefit computing. And many other applications came out of there. The first laser printer was developed in that facility, object-oriented programming, graphical user interfaces, as well as the internet working that we have seen. 1990s, the internet era showed extension of that idea of computer networks. All the computer networks that were initially developed for inside office use were similar computers being interconnected together. What made the Internet era possible were technologies that allowed different machines and different operating systems to share data and interconnect. The first beginnings of the Internet era came out of actually the late 1960s, early 1970s, as a result of the ARPANET project that the government developed for interconnecting research establishments across the country. In 1976, the first two-network application of connecting computers across the country came out. And in 1977, three networks and an important software development, TCP, allowed interconnection of multiple machines. The first interconnection of the ARPANET and thus the Internet in Silicon Valley came into the Stanford Research Institute and was often used for sending messages to and from this communications vehicle that again is now part of the Computer History Museum collection, used to develop the technology at the Stanford Research Institute. One of the first commercial applications of the Internet came out of a lot of work across the country. A significant company in Silicon Valley was the establishment of Cisco Systems by Leonard Bosack and Sandy Lerner in 1984, who figured out different areas on the Stanford campus had different computer systems and could benefit by coming up with a technique of allowing those different systems to be interconnected. And based on software technology developed by Bill Yeager, Cisco was established as a company in 1984 and created this Cisco AGS, or Advanced Gateway Router, that allowed different computers to interconnect via the Internet. This again is another exhibit in the museum. And of course, Cisco developed into a very significant company in the Valley. And when I put this slide together, probably 4 or 5 years ago, something like 85% of Internet traffic worldwide traveled across Cisco's systems. I don't know what number is today, but I'm sure it's still a very substantial number. And Cisco did work together with the Computer History Museum to develop their own in-house museum, the Cisco Heritage Center, which is on their campus in San Jose. Early Internet applications that will be familiar to some of the viewers here: Netscape, Alta Vista, Yahoo, and later applications still important today, Facebook, Google, and eBay, all came about with the advent of the hardware technology developed by Cisco and others. Coming up to the era of the 2000s, this I'm calling the mobile computing era. These are familiar to many of us today, of course, laptop computers, GPS systems, and internet-connected smartphones such as the Android system shown here. Much of the work of this, of course, started before the 2000s when it became significant as a technology. Back in 1996, Palm Computing developed a handheld device, the Palm Pilot, that was one of the first mobile computing devices and established the popularity of this kind of product for personal applications in a mobile world. Many companies were involved in then taking this idea, including a company that span out of Palm Computing called Handspring, that actually applied this technology to a mobile, combined the idea of a mobile phone with a computing device. But the major beneficiary of this, of course, was Apple Computer, who took the basic concept developed by the pioneers in the area and basically created a whole line of products, personal digital electronic products. The iPod in 2001, music player. The iPhone came out in 2007. That's why I put the Apple Inc. now with the date 2007 here. They dropped the Apple Computer name in favor of Apple Inc. to indicate that they were in many other areas than just laptop computers. The iPad came out in 2010, and of course the iWatch in 2014. showing the evolution of this technology. And Apple itself, by promoting and being so successful in the marketplace with the look and feel of their products, became the world's most valuable technology company, and built this massive new headquarters in Cupertino, an Apple visitor center just outside that, where you can look over into the Apple campus. So we're now up to the 2010s, an era of yet another advancement in technology ideas. There were many different candidates going into the decade that I could have chosen to typify it, but now looking back over the last 10 years, I believe that the most significant hardware application that came out in the 2010s was the development of special processors and of course special software to enable all kinds of applications, from artificial intelligence in autonomous vehicles, driverless cars, drones, and many other ways that artificial intelligence is being used to manage the modern world. So, over the last 30 minutes or so, I think I've covered the most significant developments that came out of Silicon Valley. Every one of them and every company had many successes, many failures, but have created an area with technology which is now world famous. And much of the story of this, if you're interested in seeing the hardware that was used and the applications that it was used, is now present in the Computer History Museum, located at 1401 North Shoreline Drive in Mountain View. The Computer History Museum started on the East Coast in the 1970s and opened in this building in Mountain View in the early 2000s. And if you're looking to see some of the artifacts that came out of Silicon Valley, many of those are exhibited in our Revolution exhibit. These are just a few snapshots of what is there. Revolution, the first 2,000 years of computing. There's 20 galleries that take you from computing from the days of the abacus to the days of the internet and mobile computing. And more recently, a new software exhibit has opened to show how all the hardware that we've talked about here in Silicon Valley is developed and how it is applied to applications in our everyday world. So if you're interested in learning more about the history of technology in general and the history of technology in the Silicon Valley, I can recommend you visiting virtually today, of course, with the current coronavirus situation in the world, but also physically at some point in the future. The Computer History Museum will reopen and you can take advantage of this wonderful collection of technology that's open to the public. The focus of the museum has changed significantly in recent years from just collecting hardware and software to a focus much more on the implications of computing technology on modern society. And the current slogan, CHM decodes technology for everyone. Thank you for watching my story today.